When I was in the sea level projects here, they asked me to be an expert reviewer for the IPCC 2000, and then came to that one. I was very surprised about the sea level chapter because it was written by 38 authors. Not a single one was a sea level specialist. Okay? They were mostly meteorologists, even 3 meteorologists from Austria. Austria doesn't even have a coast. Okay? So we begin with this. Of course, we don't lead ignorance, not exaggeration, something sound evaluation. What are the facts? And I hope I will contribute to this. Why would sea level change today? Okay? In a longer perspective, it's if the ocean volume would increase due to glacial melting, if the water column would expand due to heating, and if the water masses would move laterally due to currents, rotations. All those factors can be handled as 2 rates and amplitudes. Quod erat demonstrandum, which I want to try to demonstrate for you, hopefully. We take the glacial melting. There is absolutely no possibility in the world to have something exceeding 1 meter in a century. Because when we had all the glaciers from the ice age, and when they melted with an enormous forcing 10,000 years ago, an ice front melted over Stockholm area with 300 meters per year, and despite the fact that it advanced at the same time by 500 meters. So it melted by 800 meters per year, an enormous rate. Still the rate was 10 millimeters per year. You can never, ever beat that. It's impossible by physical. So this is physical frame of possibility. So when Ramstorff and the other are outside, they doesn't know the game. They don't know what they are doing. We must be inside. This is what we have been recording in the last 300 years. IPCC there. Somewhere here we have everything outside is just unrealistic. Then we come to the heating of the water column. This is the water expansion, and there is a water column affected. Of course, you cannot affect 6,000 meters. It's just impossible. It's physically impossible. You have to heat the surface. And if you heat it up by 2 degrees, the 300 meters, which is enormous, you don't have 2 degrees. So it's, of course, all over the oceans. It will be 10 centimeters. That's absolutely a maximum. But that is when you have 300 meters. If you come to 100-meter column, it goes down to 3.5 centimeters. And if you are 10 meters, we are coming closer to the shore, of course. Right? 10 meters depth, it's 3.5 millimeters, and you come to the shore. What is it at the shore? 0, of course, because there's no water to expand. It's as simple as that. And if you take the 700-meter expansion, which have been recorded in the last 40 years, it's 3 or 4 parts of a degree. We are down here, we are in millimeters, and of course at the shore it's 0. We have to remember that. Then we come to where the water is sitting. The water may move laterally. And for example, here we have a case. It was high there in March 97 and low there. In December, what is the opposite? High there and low in the other place. The sea level changes, the true facts are to be found in nature itself, of course. Certainly not in the modeling table. You know, sitting there, ba, 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 and inventing things coming into their minds. It's not realistic. So we have seen this man before. He said the world's most vulnerable country is Bangladesh. And the United Nations said in 2005, they said that we will have 5 million climate refugees by 2010. We have passed 2010. We don't have any refugees. What kind of stories are this? And this is the reality if you go to the field, how sea level have changed there. So, of course, this is fiction. That's the facts. Okay, we come to another one. What do we do with meaningless long-term averages? That is the purple line. Or should we take real dynamic segmentation? This is the difference between facts and fiction. So in Mumbai, that's Bombay, the real tide gauge story is of a flat, rising, falling, flat. And the purple line means absolutely nothing. So if they come to the president and say, it's a rise of 0.7 millimeter per year, what's that? That is a mean of something which shouldn't be combined. It is the last segment, which is a segment which is today's. If it will go up or down in the future, has nothing to do with what's happened before. It's not a cycle. So we come to a map, a satellite map. Here it's high and there it's low. Everybody can see that. But when you go to tide gauges in Tuvalu, in Kiribati, you can see there's a long-term record. It's absolutely no rise there. They are flat. Can you see that? Yes. Okay. And if you go in the one which should have been falling, for example, in Galapagos Islands, it's also straight. Of course, there is a high, but that is the high of the El Nino, and it's a low of El Nino there. You cannot combine that because that's a nonsense thing. And even in Hawaii, in that side, it is not as the satellite is telling you. So what do we do with a map which doesn't agree with observation? Why should we consider the map? Why should we consider the map if it doesn't work? It must be wrong. It is as simple as that. Okay, we come to satellite altimetry, which is a strange thing. It's a wonderful tool, but you must use it correctly. So there have been jumps in the trend of subjective calibration. They have inferred calibration. So this was the first time record. Okay? Then suddenly it jumped. That one got a trend of 2.3 millimeter per year. And then was another jump, so it got a 3.1. The same database is being altered. Not because it was extremely high, so you got a mean rate. It has nothing to do with statistics. It has only to do with your own calibrations. Calibrations to get it correct. And to get it correct, it means what you have in your pocket. You want to have it as people say it should be. So it is a satellite reading, it's technical adjustments, and then you get the instrumental record. The instrumental record is about 0. And it was used in the first record, and I tilted it down here. The yellow line is interesting because I think I have to go close there because that is the gravity signal, which we will see soon. If they make personal calibration, you get up to 3, and that's this trend. And look here, this gravity signal has now come up there, and the gravity signal is the following. This is the measured, and that's the other is calibrated. Calibrated. How could you be sure that it is correct? The only sure is that it fits with the data you want. My friends, we have solved the question. But this is incorrect. You shouldn't handle that in this way if you are a scientist. So sea level changes. Some of us are to record and understand, and those people are the sea level specialists. Other people just want to glorify a model, and those are the modelists and the lobbyists. So we have the tide gauge records from uplifted area to subsiding area. And in the middle, you have something of the most of the record. It's 68 data points, far below the IPCC estimate, far below, running between 0 and 2 millimeter per year. So 1 millimeter plus and minus 1. Out of this, of course, people can select. So for Douglas selected 25 points, Church 6, and Holgate 9. But of course, they selected it so they got what they wanted. We can pull it in. Now we have 204 stations in the NOAA record. And this is a histogram, so it's a little better drawn. Of course, in the whole of the data set, the mean is 0.7 millimeter per year. But if you take out the outliers there, it goes up to 1 millimeter per year. So certainly, this is, you cannot have larger sea level rise. The satellite altimetry up here, far beyond that mean. That's strange. How could it be like? And IPCC's data is, again, very much above it. Still, much of those records is a little exaggerated. Why? Because they take mean, as I showed you in the Mumbai record. They take mean of a longer term, and then the rise between the beginning of the 20th century and 2040 affects the readings. So observational phase, I'm like the Indian Ocean. Okay, I have already spoken about the Pacific, Kiribati and Tuvalu, taken a few examples. Now I will turn to the Indian Ocean. I will talk about that region. It means India, Maldives, Bangladesh, a little note on St. Paul's Island, and then go to Perth, Fremantle, and after that I go to eustatic tests. Eustatic, that means the true sea level changes. Okay, in St. Paul Island we have a very nice reading in 1878, and during this period sea level has not risen in 135 years, and contrary to all those models. In the Maldives I worked extensively. All the red points are C14 dated points, and the squares are what they compare to with respect to sea level position. So we have a very, very detailed curve of the, we will especially concentrate on the last 500 years. Here we have, for example, 4 and 3, the high levels. You have something, you're up there at the top you see a shore. That is number 4. The man number 3, he is standing on this high, and 1 and 2 is the high water and the present mean high tide level in a lagoon. That's a lagoon. And we have also buried peat bog, and we have the lake level rose because sea level dated 790, and it was a stable period, and then the lake dried because sea level fell. We see erosion here in the other place. The sand, which is being remobilized, was taken, and look here, it was deposited not on the land, because if sea level would have risen, it would be attacking on the land. But it is outwards, downwards, because sea fell. And the old shoreline is there. There you can see the shoreline. That's the old shoreline earlier. In the Mali, there is a tree. This tree has a very, very delicate position, because you can nearly blow on it and it will fall over. It has stayed there for 50 years. So sea cannot have risen. And when I told this and came back in 2003, it was lying down. We were shooting a film. And it was very sad. And as an honest scientist, I thought, wow, I was wrong. But then I asked in this little restaurant, when did the sea take the tree? They said, no, the tree never take it. It was a group of Australian scientists which pulled it down by hand. It's very nice people, you know. And then I pulled it up because it was still green, and we shot the TV program. Then we have a double rock cat platform. Rock cat platform means the stability of the sea. Before 1970, sea was here, and we have a very nice map from 2022, where showing this. Now, sea level is eroding this rock cut platform. And there's absolutely no attack inland. So there is no tendency that sea is rising. It's a very stable position. So it has been so for 40 years. So this is what we have. We have a beach ridge dated, we have the peat, we have this lake level, and we have a fall, and a very nice stability by a lot of different variables for the last 40 years. And then we had a strange man, the old president. We were standing in the water, and he was a cabinet under the water trying to see that they were going to be flooded. But as a matter of fact, in our progress, our prediction in the coming 2100, I mean, if anything happened, it's just a return to the level before, and they didn't even notice that sea level had lowered. So it's no problem. Even this one, they succeeded very well with. And this is the closest island to the Maldives, in the Laccadives, Minikoi. And the old man says, when I was young, sea was here. Okay? And it's again, after this sea level fall, it has been stable for 40, 50 years. There is no traces whatsoever of a sea level here. And they were amused by the president in Mala. And they understand it's all a matter of money, because they want support from outside. We go to Bangladesh. We see a coast like this, and the IPCCers would say, oh, wow, sea is rising. It has eroded the old forest. But then you go a little closer. Look at the tree trunks. And what do you see? You see horizontal roots. It's mangrove trees. That means that the original mud cover was up here. So there is no rise. As a matter of fact, if you extrapolate it, it's a little higher inside the delta surface. So and in both sides of the interior, these are the tide gauge. We have seen that before: stable, rising, fall, and stable. This stability is exactly what we see in Bangladesh. Then we go to Goa, India, where I have new material not exposed before. We have here a very nice undercut by the sea. Sea was 60 centimeters higher. It's very easy to, because you measure that to the algae rim, which is today. And we have a harbor inland. Now, of course, we have a picture, painting with an old harbor. We have a drained harbor, we have a submerged harbor, and then we have a double rock cut platform. This one, which is 20 centimeters higher, and a present one where with living mollusks and algae. And this means a stability in the last 50 years. And you can see it here, the same thing. This is the higher rock cut platform, and that is a cliff. It's not active any longer because it's overgrown. Okay? And this is the present high tide level, and here is the active erosional cliff. So we have very strong data. And if you put it together, it's a very coherent picture in the whole of the Indian Ocean that for the last 50 years, sea level has not been in a rising mode. That's the facts. So what this is giving, it gives you not a global warming, but global warning. It's not this picture, but it's disinformation and misunderstanding, and there will be no flooding in the future. We go to Perth, Fremantle in Perth. If you take the last part here, you may come up to figures of 6.5 millimeters per year. That's what the government, Australian government, is using. But that's a misuse, because those things will never stay in the future. So if you extrapolate it, where do those lines go? To hell. Yes, that's right. If you take the long-term mean, it's 1.5 millimeters per year. So that is some sort of mean relative sea level changes. But we can do it better. You can do a dynamic analysis, and then you go down to 0. And the dynamic analysis I will explain for you. So if the mean relative was 1.5 millimeter per year for the whole data set, from 1913 to 1956, it was a rise of 2.5 millimeter per year. At the same time, global sea level rose by 1.5 millimeter, 1.1 millimeter per year, about. And that means it suggests, not my wording, suggests subsidence of 1.4 millimeter per year. That is the purple line. If you then combine that with the yellow line, it's really very little sea level changes. And in the last 50 years, it's absolutely the same, precisely as in the rest of the Maldives, in the Indian Ocean. No sea level rise at all. So observational facts in Europe. We go to Venice, because Venice is supposed to be a critical area both for culture and for sea level. Here we have very nice data from 1730. So we get the subsidence rate, that's the blue line. On top of that, we have the tide gauge record, the purple one. And of course, it follows this line completely. That means that there's no tendency of a sea level rise. And if you go here, if it would be an acceleration, it should go up here. It's the contrary. After 1970, it goes down. This has something to do with engineering. But if you look at the Trieste tide gauge station, it's a similar record. So it's also a global signal. This means that 4 years ago, on this exactly very day, when it was flooded here, it has nothing specific. It's just the same time for the last 60 years. So there is nothing new there. If we go to Cuxhaven, which is an important thing, you can make a sinusoidal line for the relative sea level curve. And because we have other geostatic solution from Amsterdam, we can say that the subsidence is about 1.4 millimeter. That's the red curve, and then the geostatic component, that's the difference between those two. The important thing here that we can add up to the present. And where is the acceleration? There's no acceleration. We can transfer it into the absolute sea level curve. This is the difference. This is Amsterdam, and this is Cuxhaven, so it's a little different. Amsterdam, sorry, Cuxhaven. But the important thing is the continuation here. It is no rise, and it should go up there. And this fits very well with the Earth rate of rotation, which I will soon come to. If satellite altimetry we will correct, I mean, it would be absolutely, we would fall into nonsense, because both Cuxhaven and Amsterdam would go up. It would be uplift with a tremendous rate, you know. This is just turning everything on. This is not geology. This is not science. It's not logic. It's nothing. It's just a mistake. So what about the notorious sea level? Facts or fiction? Okay. I will explore a little the Earth rate of rotation. First of all, we have, this is the European sea level curve, rising by 11 centimeters in the last, after the little ice age, post-little ice age, sea level rise, A. B, because sea level is rising, because the Earth radius is expanding, it has to affect Earth's rate of rotation. It must be a slowing down. You know, the figure skater. She is turning around with and she has the arms here to spin fast. And then when it's time to slow down, she delicately puts her hands out and the spinning goes down. Okay, so here it's a deceleration. And that curve transferred into sea level is about 10 centimeters. So it's a very, very good correlation. And also a time lag. Of course, sea goes first and then Earth rate of rotation. Becomes effective. If we turn now to the last part, Earth rate of rotation for the up to today, we can see from 1972 to the present. It's a generally slow, speeding up, okay? So that means it's contrary, cannot be a sea level rise, which is interesting, which all people are talking about. So if we go back to this here, sea level would be, if sea level would, following the law of angular momentum, the Earth should experience a deceleration, slowing down. This is not the case. Why is this? Because science is not rising, of course. So if I combine these things and some sort of observation rates in millimeter per year up to 2012, and then a prediction in meters in year 2100. We have this curve. It accelerates here in the 20th century, and today, in the last 50 years or so, it has remained stable. If anything, from the tide gauge record, it may be 0.5 millimeter or so, but not 1 millimeter per year, not 2, not 3.0, for sure not. We must be down here. And if we go to year 2100, our prediction is here, just as we did 12 years ago, and the IPCC are far above this value. And of course, we have already noted this sea level rise in 1 meter or more is nothing but sheer nonsense, whatever Ramsdorff, Hansen, Church, and others may say. You have the observation. This is a physical frame. You cannot beat that. And Hansen's curve is, of course, the most remarkable thing in respect of nonsense and disinformation. Here, he will rise in 200 millimeter per year. This is the curve of maximal possible for physical laws, and we are down here somewhere. So why are they doing like that? So we can answer sea level changes. We are scientists. I am a scientist. We observe, we record. No, sea is not at all rapidly rising. Maybe at the most 10 to 50 centimeters by this year. The other guy, Hansen, for example, we are lobbyists. We promote an idea. Yes, we want to scare up people to action. So why not 1 meter or more by 2100? There are lots of lies and exaggeration linked to global warming. People may behave so, but trees doesn't lie. And we have this tree in the Mala, we have those trees in the Bangladesh. They don't lie. So I can not endorse by observational fact, I cannot endorse this. The observational facts are down here. So I think that this personal selection models and so doesn't hold. So we go back to our best estimate, just as we did long ago, by 2008. It's 5 centimeter plus and minus 15 centimeters. And this is my final conclusion. The end. Many thanks, and I'm an old sea level specialist.